Hello students, welcome to 60 out of 60 in KSET Chemistry 2025 series in just 200 days. So yes, today we are going to revise the alcohols, phenols and ethers chapter. Okay, so in my previous lectures we have completed this chapter like fully. So today it's time to revise. We'll just revise what are the different methods of preparation, chemical reactions, and we will practice 15 important questions from this chapter. Okay, so yes, now I want everyone to sit with a sheet of paper and pen so that you can make flow charts, you can make a revision note, a short note for this chapter. Okay, so now without any delay, let's get started. So one more request here, please join our WhatsApp channel so that you can get access to all these class notes, PDF, question paper, solutions, everything is available in our WhatsApp channel. So please join the WhatsApp channel, and to join the WhatsApp channel, the link for that is given in the description section of this video. So you can go there, download, join the link. So click on the link and then join the WhatsApp channel. Okay, so yes, now let's get started. So this is what we have done in this chapter, how we have completed this chapter. So you should know this to have a revision. Okay, so first part we discussed classification. One second. So first part we discussed about classification, and then we discussed about nomenclature, and we discussed about structure. In part 2 we discussed about preparation of alcohols, preparation of phenols and the physical properties. Part 3 we discussed chemical reactions of alcohols and chemical reactions of phenols, and in the last part we discussed about commercial alcohols and ethers, right? Fine. So in weightage wise, you can know this chapter easily, you can expect 3 to 4 questions. So very high weightage chapter and a must do topic. Okay, fine. Now we'll go to the first topic, that is preparation of alcohols. So first of all, preparation of alcohols can be done from 3 different sources. First one, using alkenes, second from carbonyl compounds, and third from Grignard reagent. Okay, now from alkenes there are 2 methods, by acid catalyzed hydration, and the next one is hydroboration oxidation. Okay, next from carbonyl compounds we have reduction of aldehydes and ketones, and we have reduction of carboxylic acids and esters. Okay, and then from Grignard reagent. Clear? So alcohols preparation, there are 3 sources: alkenes, carbonyl compounds, and using Grignard reagent. Under alkenes we have 2 methods, acid catalyzed hydration and we have hydroboration oxidation. Under from carbonyl compounds we have reduction of aldehydes and ketones, reductions of carboxylic acid and esters, and then we have using Grignard reagent. Okay, so in total if you count, we have 1, 2, 3, 4 and 5 methods of preparation of alcohols. Okay, so now you can see these all methods here. So first one is from alkenes. If you treat it with H plus and H2O, then alcohols will be produced, like H and OH is added to the double bond, and here Markovnikov's rule is followed. Okay, Markovnikov rule is followed. Like for example, if I give you, we have propene. Okay, so I'll just make here propene, CH3, CH double bond CH2. Okay, now if you treat here with H plus and H2O, that is acid catalyzed addition of water. If you add H plus and H2O, acid catalyzed, so what will happen? Markovnikov's rule will be followed, and the negative part, that is OH, will go to the carbon having less number of hydrogen. So what will be the product I'll get here? CH3, CH, OH, CH and H. Okay, this is on H plus and H2O, Markovnikov's rule is followed. The second method, that is hydroboration oxidation reaction. Here what happens? Here anti-Markovnikov rule is followed. Anti-Markovnikov rule is followed. Okay, so if this same propene is there and you treat it with this one BH3 whole 2, or you can write it as B2H6, then H2O2 and OH minus. So this one will give you a different product, that is it will give you anti-Markovnikov's rule. So OH will be added to the carbon having more number of hydrogen. So what I'll get here? CH3, CH, here H will be added and here OH will be added. right? So you can see the difference between the two products. This is Markovnikov product and this is anti-Markovnikov product. So from alkenes we can use two reagents to get alcohols. One follows Markovnikov's rule, another follows anti-Markovnikov's rule. I hope this alkene part is clear. Next, coming to reduction of aldehydes and ketones, right? So you can see here this one, aldehydes and ketones we can use. So here what are the reagents we can use? H2 palladium or NaBH4 can be used to reduce aldehydes or ketones to alcohols. Like for example, if you have like CH3COH and you treat it with, suppose one second, so if you treat it with NaBH4, okay, you treat it with NaBH4, then what will happen? This double bond O will get converted to OH. So what I will get? CH3COH, okay, this one got converted to OH and here there is already one H, okay, and to balance it we need to take one more H. You just need to add H and OH. Clear? So like this we can reduce aldehydes and ketones. Now if you have acids and esters, okay, acids and esters can be reduced by using LiAlH4 or hydrogen palladium. Okay, let us take one example of an acid. So for example, I have CH3C double bond O OH, and if I treat it with LiAlH4, so what will happen here? Again, this part will get converted to OH, so we will have CH3C, this one I will convert it to OH. Okay, next the rest of the carbon valencies are balanced using hydrogen. Okay, so that is over. Next, using Grignard reagent, so you can take any aldehydes and ketones and treat it with Grignard reagent. Okay, so here what happens? You should remember, this is delta minus, this is delta plus, this is delta minus, this is delta plus. So this R minus will attack on this carbon, okay, and we will get a alcohol. Like for example, suppose we have CH3COCH3, okay, and I am treating it with RMgX. Okay, so we can just assign plus and minus here first. So you can see this is carbon is plus, oxygen is minus, this is minus, this is plus. So now this R will attack on this carbon and we will get product here like this, CH3, okay, C here OMgX. This is minus, this is plus, so we'll get OMgX here, and this one will be plus and minus. So R will come here and we will get CH3. Then with hydrolysis, so here after this you also need to give H3O plus, and that will convert this OMgX to OH. Okay, so this will be the product here. Getting? So now we have done all the 5 methods of preparation of alcohols. From alkenes we have 2 reagents, H plus H2O and BH3 H2O2 OH minus. Clear? From then you can treat aldehydes. So third one, aldehydes and ketones using NaBH4 or hydrogen palladium. Then esters and acids using LiH4 and hydrogen palladium. Then the fifth one is using Grignard reagent. Okay, so in Grignard reagent it's very simple, you just need to identify R minus and Mg plus. Okay, after that we'll go to preparation of phenols. So preparation of alcohols, how many methods are there? 5 methods are there. You must remember this one. Now preparation of phenols, we have 4 methods. Okay, so first one is using haloarenes, from haloarenes. Next one using benzene sulfonic acids. Next one from diazonium salts, and the last one is from cumene. Here you should remember that this method is the commercial method. Okay, from cumene the production is the commercial method. Okay, so we have 4 from haloarenes, from benzene sulfonic acid, from benzene diazonium salts, and from cumene. Okay, let us see these 4 methods. So first one is from haloarene. This is the first method, from haloarenes. Okay, so you can just take chlorobenzene and then convert it to phenoxide ion. Okay, but here you have to remember NaOH should be taken at a very high temperature and high pressure. Now once you get this O minus Na plus, then you can treat it with HCl. So what will happen here? This OH will come and NaCl will form. Okay, so first of all, from haloarenes we can use convert it to phenoxide ion NaOH by treating at very high temperature and high pressure. Then you can treat it with HCl, and once you treat it with HCl, we will get phenol here. Okay, next one. Next one is your from benzene sulfonic acid. Second method. This is second method from benzene sulfonic acid. Okay, so first we need to get benzene sulfonic acid. So from on benzene, if you treat oleum, oleum is what? Concentrated H2SO4. So we will get benzene sulfonic acid. After this, just treat it with NaOH H plus. Okay, so this one will convert this to phenol group. Okay, now third one is using benzene diazonium chloride. The third method is from benzene diazonium chloride. Diazonium chloride. Okay, so how to get benzene diazonium chloride? First you need to take here aniline. Okay, aniline should be treated with NaNO2HCl. Okay, once you treat aniline with NaNO2HCl, you will get benzene diazonium chloride. Okay, this is your benzene diazonium chloride. Now with benzene diazonium chloride, you need to treat warm water, then this will give you phenol. Okay, and the fourth one, the one I told you, the commercial method, very very important one, that is your from cumene. Okay, so first this compound name you should remember, this is called as isopropyl benzene or cumene. Okay, isopropyl benzene. Now first you need to treat this one with oxygen. So here there is oxidation taking place, so OO is added here, and then H plus water if you treat, we will get this one, phenol plus acetone is produced. Okay, so byproduct here phenol plus acetone. Okay, must remember this byproduct also. Okay, so four methods clear. First one is using haloarenes. We can take any chlorobenzene or chlorobenzene and then treat it with sodium hydroxide at a very high temperature and pressure. So this will give you sodium phenoxide ion. Now once you get sodium phenoxide ion, you just need to treat it with HCl. Okay, so you will get phenol, first method. The second one is using benzene sulfonic acid. So first we will take benzene, treat it with concentrated sulfuric acid to get benzene sulfonic acid, and then you just need to treat it with NaOH and H plus. We will get phenol. The third method is from your benzene diazonium chloride. So benzene diazonium chloride is produced from anilines. When anilines react with NaNO2 and HCl, will give you benzene diazonium chloride. Once benzene diazonium chloride is produced, then you can treat it with warm water. Okay, so that will give you phenol. And the fourth one, most important commercial method, is from cumene. Here we take isopropyl benzene, treat it with oxygen, so that gets oxidized, you get OOH bond here, then you just need to do hydrolysis. Okay, H plus water. Clear? So I hope this preparation of preparation of phenol is clear. So here we have four methods. Okay, so preparation of alcohols 5 methods, preparation of phenols 4 methods. Next we'll go for preparation of ethers. So here preparation of ethers has 2 methods. First is dehydration of alcohols, and the second one is Williamson ether synthesis. Okay, this method is very important. Okay, Williamson ether synthesis, very very important method here. Now dehydration of alcohols, here you should remember the temperature required is 413 Kelvin. Okay, this is important here. Now let us see what happens. So dehydration of alcohol, if you see, we have taken ROH plus another R dash OH, suppose. Okay, then what will happen? Here there is dehydration taking place. Okay, dehydration will take place, and we will get this dehydration takes place at, what is the condition? Concentrated H2SO4 at temperature 413 Kelvin. Okay, at temperature 413 Kelvin. So here H and OH will go, and we will get RO R dash. Okay, this is the ether produced. Now I will discuss the mechanism briefly in the next slide. Okay, and Williamson ether synthesis here. So let us go to the next slide. We'll discuss there in detail. So first see dehydration of alcohol. first step what happens, we have taken ROH, okay. In the presence of concentrated H plus, it gets converted to RO plus H2, okay. That is called what? Protonation of alcohol. Mechanism is not us, but just we will revise quickly. Now what happens, there is another ROH, so we will take in different color, okay. We have another ROH here, so I'll write it at R dash OH plus this protonated one, okay, that is RO plus H2. Now this lone pair of this one will attack on this, okay, and this water will go out. So what will be produced here? R dash, we have R dash, we have O, we have H, and then we have this R here, okay. Now what will happen, this H plus goes out, okay, so we will get here R dash O R, R dash O and R, okay. So this is the ether, clear? From the alcohol, dehydration of alcohol, here the temperature, this dehydration takes place at 413 Kelvin, okay. This is important, temperature you must remember here, okay, because if you do the dehydration at a higher temperature, 443 Kelvin, there takes place alkene is produced, okay. At 413 Kelvin, ethers are produced. Now coming to next one, that is Williamson ether synthesis. So in Williamson ether synthesis, what happens, we have two things. One is Rx plus R dash ONA, okay. So what are these reactants called as? So this is your haloalkane, or I can say alkyl halide, okay. This is alkyl halide and this is alkoxide, okay. So now what happens here, see, this is delta minus, this is delta plus, okay, and this is delta minus, so this RO minus attacks on this one and this goes out, so we get here a product of ROR dash plus NaX, okay. But here there is a catch that you must remember, okay, very very important, that this alkyl halide must be a primary one, okay. This is very very important, that you must remember, the alkyl halide which you take should be a primary one, okay. Now for example, see, suppose you want to synthesize this CH3, 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 OCH3, okay. Suppose you want to synthesize this ether, okay, you can take one alkoxide ion and one halide ion, that is your alkyl halide ion you can take. Now there are two combinations possible here. See, I can take that, this part, okay, CH3 whole 3, okay, O minus Na plus plus CH3X. This is one combination which I can take. Another combination I can take is CH3 whole 3 CX plus CH3O minus Na plus, right. Now as I told you, the halogen part, the alkyl halide part must be primary, right. So here you see the alkyl halide part is primary, but if you see here, the alkyl halide part is tertiary, right. This is tertiary and this is primary, okay. So in that case what will happen, which is the correct method? So the first one where we have taken the primary alkyl halide, okay, this is the correct combination, okay. This combination will not work. Why? Because we have taken here tertiary alkyl halides, clear. So that is why always remember that the alkyl halide must be primary. Primary alkyl halide is required. Now if you take tertiary alkyl halide, then what will be the product? The product will be alkene, okay. In this case, the product we will get is alkene, okay. So I gave arrow mark wrong way, it should be in this way, okay. This one should be alkene. If you take in this combination, then we will get alkene as a major product and not ether, okay. So preparation of ethers, so this is preparation of ethers, okay. We have only two methods, okay. So now if we revise, alcohols we studied 5 methods, phenol 4 methods, ethers 2 methods. So 5 plus 4 9 plus 2 11. So total there are 11 methods of preparation, clear, okay. Next coming to reactions of alcohols. Okay, next we will discuss about reactions of alcohols. So first, alcohols can react in two way. Okay, there is a cleavage. One reaction is there where there is cleavage of OH bond, another is there where there is cleavage of CO bond, right? So now if there is a cleavage of OH bond, then what type of reactions are shown? Reactions with metals, acidic nature of alcohols, and esterification. Okay, these are the three types of reactions which comes under cleavage of this OH bond is breaking. Okay, and next, cleavage of CO bond. In this you have first one reaction with HX. Here one very important thing we'll study, that is your Lucas reagent. We'll study about Lucas reagent. Then reaction with PX3. Okay, next we have dehydration reactions, and then we have oxidation reaction. Okay, so total if you see alcohols reactions are of two types. One is cleavage of OH bond, under that we have reactions with metals and esterification. Acidic nature, acidic property of alcohols is defined by the cleavage of OH bond. Okay, here there is no reaction in all, like you don't have to study in reaction here. So cleavage of OH bond, two reactions. What are they? Reactions with metals and esterification. Next we have cleavage of CO bond. There are four reactions. So what are there? Reactions with HX, reaction with PX3, dehydration, oxidation. So here 4 and here 2. So total we have 6 reactions. Okay, alcohols we have 6 reactions. So let us quickly see them. The first one, that is your reactions with metal. Okay, so where there is cleavage of OH bond. Okay, so now what happens, you can see ROH is there. So we have ROH. Okay, and when you treat it with Na, okay, this bond will break. So RONA will form, and this H will give you H2 gas. Clear? First one. The second one is your esterification reactions. So esterification reactions, for esterification reaction, okay, we need 3 things. 3 reactants can be there. Okay, the first one is your with acids, with carboxylic acids. Next is with anhydrides. Okay, and the next one is with we have with acid chlorides. So these 3 compounds can react with alcohols to give you esters. Okay, so this is the first one, you can see where alcohols are reacting with acids. Okay, next you have alcohols reacts with anhydrides. Okay, and next we have alcohols reacting with acid chlorides. Okay, so now question, we'll just see how this mechanism is happening. Okay, so you just need to understand that OH bond will cleave here, right? So RO part from here, okay, and COR dash part from here is taken to give you this alcohol, sorry, this esters. So what will happen here? These are your esterification reactions. So we'll get here again RO part from here and R dash CO part from here will give you again esters. Now RO part from here and R dash CO part from here, right? These two will again combine to give you this one. So what is left here? H and Cl is left, so to give you a byproduct of HCl. Here if you see H and OH is left, so that will give you a byproduct of water. And here if you see we have one more R dash COO, this part is there, R dash CO another, and this H will give you acids here. Okay, so you can check this. So under reactions of alcohols, where there is cleavage of OH bond, there are 2 main reactions. One is reactions with metals and another with esterification. Now esterification can happen with 3 different reactants. Alcohols can react with carboxylic acid, acid anhydrides or acid chlorides to give you esters. Okay, so that is about the reactions of alcohols where cleavage of OH bond is there. Now we'll go to the reactions of alcohols where there is cleavage of CO bond, right? Here we had 4 reactions. So if you remember, the first one is reaction with HX. Okay, so here what we get product? RX and water. Here I told you one very important thing, that is Lucas test. So you should remember what is Lucas reagent. So Lucas reagent is HCl with anhydrous ZnCl2. Okay, this is Lucas reagent. Now here what happens? The tertiary one, okay, so I'll write here tertiary alcohols reacts faster, secondary alcohols reacts in 5 minutes, okay, and the primary alcohols do not react. Okay, so this can be used as a test for alcohols, right? This Lucas test or Lucas reagent can be used as a test to differentiate between primary, secondary and tertiary alcohols. Now what happens in reacts in if it is a tertiary alcohol, it reacts faster, and what we get? Turbidity. Okay, turbidity is due to this formation of Rx. Okay, turbidity is due to the formation of Rx. First reaction over. Second one is reaction with PX3. So this reaction we have already studied in the haloalkanes and haloarenes chapter. So you will simply get Rx. So if you treat with PCl3, we will get RCl. If you treat with PBr3, we will get PBr. Okay, RBr we will get. Next one, the third one is your dehydration reaction. So dehydration reaction takes place with concentrated H2SO4 at 443 Kelvin, or you can use H3PO4. Okay, so dehydration, so this is your third reaction, that is dehydration. Okay, so here what we have to remember, that the order of dehydration is 3 degree, 2 degree, 1 degree. Means 3 degree alcohols will react faster towards dehydration, then 2 degree alcohols, then 1 degree alcohols. Okay, next one we have fourth reaction, that is your oxidation, right? Fourth reaction is oxidation. So here very important thing, listen, alcohols can be oxidized, okay, to give you aldehydes. Aldehydes can be oxidized to give you carboxylic acids. Okay, now primary alcohols, okay, so remember here primary alcohols, if you do mild oxidation, okay, then they can be get converted to aldehydes. If you do strong oxidation, then they will get converted to acids. Okay, clear what I am saying? Primary alcohols on mild oxidation will give you aldehydes. Primary alcohols on strong oxidation will give you carboxylic acids. Okay, so now what happens, if you see, we have primary alcohols here, this is primary alcohol and this is secondary alcohol. Okay, so primary alcohol can be converted to aldehydes using a mild oxidizing agent. So one of this is your CrO3, chromium oxide, and if you treat secondary alcohols with CrO3, we will get ketones. Okay, next, another way you can use primary alcohols, if you treat it with PCC. Primary alcohols with PCC will give you aldehydes. Similarly, secondary alcohols also here, so I can write this reaction here, RCHOH R dash with PCC will give you RC double bond O R dash. Okay, so this is your primary alcohol and this is secondary alcohol. Okay, so what are the reagents we got from primary alcohols or secondary alcohols for mild oxidation? CrO3 and PCC. Now there is one more reagent, that is copper at 573 Kelvin. So this is very important. Here primary alcohols gets converted to aldehydes. So this is primary alcohols getting converted to aldehydes. Secondary alcohols getting converted to ketones. Right, now this is very important here. Tertiary alcohols, okay, gets converted to alkenes. Okay, tertiary alcohols gets converted to alkenes. Now let us revise this completely oxidation part. Primary alcohols can be converted to aldehydes using three reagents. What are they? So we will write here like this: primary alcohols to aldehydes. Okay, what are the reagents available? So I will make a box here. Okay, so first you can use is CrO3, next you can use is PCC, or you can use copper at 573 Kelvin. Okay, next the secondary alcohols. Okay, so we can write for secondary alcohols. So secondary alcohols can be converted to ketones. Okay, what are the reagents available here? The same reagents, that is your PCC or CrO3 or copper at 573, right? So secondary alcohols can be converted to ketones here. Okay, so I'll erase these two so that it will be little messy here. So we'll just erase this one. Okay, so now you remember And for tertiary alcohols, it gets converted to alkenes with which reagent? With copper at 573 Kelvin. Okay. Now one more question you can ask here, that primary alcohols can be converted to acids, right? I told you primary alcohols can be converted to acids using strong oxidizing agent. So what are these strong oxidizing agent? You can use KMnO4 or you can use K2Cr2O7. Okay. So these two reagents can convert primary alcohols to carboxylic acids. Okay. Clear? So now let us revise the complete reactions of alcohols once again. Okay. So if you see reactions of alcohols, we have first category where there is cleavage of OH bond. Under that we have two reactions. One is reactions with metals, first one, that is your reactions with metals, and second one is esterification. Reactions with metals will give you alkoxide ion and hydrogen gas, and esterification we have three reactants for that. You can either use carboxylic acids with alcohols, anhydrides or acid chlorides. All these three will give you esters plus different byproducts. With acids you will get water, with anhydride you will get another acid, with acid chloride you will get HCl. Clear? Now coming to the second part where there is cleavage of CO bond. Here we have first reaction, that is reaction of HX. Here you must remember about Lucas reagent, very important. Then second one, the reaction is with PX3. Third one, dehydration. The third reaction is dehydration, and here this order is important. Okay, tertiary, secondary and then primary. Next we have oxidation reaction. So primary alcohols are converted to aldehydes using three reagents. What are they? CrO3, PCC or copper at 573 Kelvin. Secondary alcohols are converted to ketones again using three reagents. What are they? CrO3, PCC and copper at 573 Kelvin. Tertiary alcohols are converted to alkenes using copper at 573 Kelvin. Okay, these are the reactions. Next, primary alcohols can be converted to carboxylic acid using strong oxidizing agents like KMnO4 and K2Cr2O7. Okay. So this is done. Next coming to now reactions of phenols. Okay. So reactions of phenols, we have some different reactions here. First one is your acidic nature. Again, like how we discussed in reactions of alcohols, there is no acidic nature as such. We'll just discuss how to predict the acidity order here. Next is, so under acidic nature you can see reactions with metals. Reactions with metals. Okay. Next is your esterification. After esterification we have electrophilic substitution reaction. Next we have Kolb's reaction. Next we have Reimer-Tiemann reaction, reaction with zinc dust, and then oxidation. So you can see here 1, 2, 3, 4, 5, 6 and 7 reactions. Okay. So in alcohols how many reactions we read? Under OH type 2, under this one 4, so total 6 reactions. Here you can see almost 7 reactions are there. Okay. Under electrophilic substitution reactions we have two things that we will be studying, nitration and halogenation. Okay. So now let us go to the first one, acidic nature. So under acidic nature, okay, these two reactions 1 and 1, these two tells about the acidic nature, or I can say reactions with metals. Okay. So we'll say it as reactions with metals. Reaction with metals. Okay, this is the first reaction, number 1. 1 second. Okay, the first reaction is reactions with metals. So under this you can react it with direct sodium, or you can react it with sodium hydroxide. So if you react with sodium, the byproduct here is H2. And if you react with sodium hydroxide, Na will come here, H will come here, H and OH will give you byproduct as water. Okay, that is the first reaction. Second reaction we wrote was esterification, that we will discuss little later. Okay, and the third reaction we had was electrophilic substitution, right? Third reaction was electrophilic substitution, and under that we had first one is nitration. Okay, so here nitration, again two cases you have to see. First is if you treat OH group, okay, it is an ortho-para directing group. Okay, it is an ortho-para directing group. So if you treat it with dilute HNO3, then at ortho position and at para position nitro group is substituted, right? This is your ortho product, this is your para product, right? Now if you treat it with concentrated HNO3, 3B, I can write it, okay, concentrated HNO3, then what will happen? All the ortho and para positions are substituted at a time. We get trinitro product, okay. So third reaction, that is electrophilic substitution. Under electrophilic substitution we have nitration. Under nitration we have two cases, dilute HNO3 and concentrated HNO3, okay. Next, coming to 3B, that is halogenation. 3B is halogenation, okay. Now what is there in halogenation? You can treat it with only bromine, okay. If you treat it with only bromine, then what will get? Since I told you this is ortho para directing, so we will get bromine in all these three positions, right. Now if you want only ortho and para products separately, then the reagent we required is Br2 in presence of CS2. So this will give you ortho and para products separately. Clear? Next one is your NaOH, okay. So here, okay, so this is your third reaction. Now fourth one I told you was Kolb's reaction. Kolb's reaction. Now what does this Kolb's reaction does? First of all, phenol is treated with NaOH, so we'll get ONA, okay. After that it is treated with CO2 and H plus to give you OH and COOH, okay. This is your Kolb's reaction. First you have to treat it with sodium phenoxide ion, we need to get NaOH, then you need CO2 and H plus to get OH and COOH, okay. This is your fourth reaction. Next, fifth reaction was what? Reimer-Tiemann reaction, right. So this is your fifth reaction, that is Reimer-Tiemann reaction, okay. So here what happens? First you treat it with chloroform, CHCl3 and aqueous NaOH. So this aqueous NaOH will convert this one to O minus Na plus, and here CHCl2 is attached. Then again you treat it with NaOH. So here what happens? Both the chlorines get replaced with OH, and then there is dehydration to give you CHO. Then you treat it with H plus to give you this one, OH and CHO, okay. This is the fifth reaction. The sixth reaction was your reaction with zinc dust, okay. So if you react with zinc dust, then what we get? Benzene and zinc oxide. And the seventh reaction, that is your oxidation, okay. Oxidation is done using Na2Cr2O7, and this one will give you quinone. Clear? So let's go back to the sheet and discuss once again. First we discussed about acidic nature, or under acidic nature we discussed about reactions with metals. Here there were two reactions I told you. One is reactions with Na and another is reaction with NaOH. Clear? First one. Acidification we haven't discussed yet. Now we will discuss. Under nitration, here we have two things. One is dilute HNO3, right, and another is concentrated HNO3. In dilute HNO3 we will get two separate products. Concentrated HNO3 we will get one product where all the ortho and para positions are substituted with NO2 group. Now if you see halogenation, here also we have treatment with bromine water. This will do all the three positions, ortho and para will be substituted, or else we can treat it with bromine and CS2 to give you separate ortho and para product, right. So here we will get separate ortho and para products we will get, okay. Now coming to Kolb's reaction, so let me erase this part, okay. So in Kolb's reaction what we did? First we treated with NaOH, okay, so that we will get phenoxide ion, O minus Na plus, and then you treat it with CO2 and H plus, we will get OH and COOH, right. The second one, sorry, the fifth one was your Reimer-Tiemann reaction. Here first what we did? We treated with CHCl3 and aqueous NaOH, right. So this gave me OH and O minus Na plus and CHCl2, right. Then again you treat it with aqueous NaOH, right. So that will give you O minus Na plus, and you have CHO here. Then you treat it with H plus, and then we will get OH and CHO. This is done. Reimer-Tiemann reaction. Next, if you treat it with zinc dust, we will get simple benzene plus zinc oxide. Now if you treat with oxidation, so what is the reagent here? Na2Cr2. Let me write it clearly. So this is just a revision, okay, what we have studied, quick revision of that. So if you treat it with Na2Cr2O7, we will get quinone. Okay, so this was the product we will get, quinone. A quick revision of all the 7 reactions that we have studied under phenols. Okay, esterification is still remaining. Okay, so now we'll go to esterification reaction. So as we had studied esterification for alcohols, okay, 3 different reagents were there. Similarly here also there is 3 different reagents. You will get acids, you can react with anhydrides, okay, and you can react with acid chlorides, right. So these 3 things will give you the same product as we discussed in the alcohols part. Now here something very important reaction is there. This is very important. Okay, see this OH and COH, you remember this one we produced, this was the product of Kolb's reaction, right. So now if you treat it with any anhydride, so what will get? OCOCH3, and this product, okay, this is very important. This is your, this compound is called as aspirin. Okay, aspirin can be a compound drug. Okay, that is the structure you should remember. From this compound we can treat it with this one to give you anhydride, to give you OCOCH3. Okay, this is the aspirin one. So done. This is very important, reactions of phenols. So how many reactions we had here? First one, reactions with metals, there it is Na and NaOH. Second one, esterification. So these 3 reactions which we have studied, very similar to the alcohols part. The third one, the electrophilic substitution, under that we had nitration. Under nitration, concentrated nitric acid, dilute nitric acid, then we had halogenation, bromine and bromine with CS2. The fourth one, Kolb's reaction. Fifth one, Reimer-Tiemann reaction. Sixth one, reaction with zinc, and seventh one, oxidation reaction. Okay, done reactions of phenols. Now we'll go to reactions of ethers. Okay, so here again we have chemical reactions of ether. First one, cleavage of CO bond. This is very important reaction. Okay, and next we have electrophilic substitution reaction. These are halogenation, nitration and Friedel-Crafts reactions. Okay, so 2 major category, cleavage of CO bond and electrophilic substitution. Under electrophilic we have nitration, halogenation and Friedel-Crafts reactions. Okay, so first we will see the first part. So here these numbers please ignore, so I can write it as 6.1 and this is 6.2. Okay, fine. Now coming to the cleavage of CO bond. Okay, so now first what happens generally when you have any alcohol, any ether, right? So these are your ethers. Okay, this oxygen has lone pair. What does it do? It takes this H plus. Okay, so once again, when I am saying cleavage of CO bond, we are talking with reaction with HX. Okay, this is the reaction that we are going to study. Okay, now see. So for after this O plus will attack here, so this is there, and then we'll have a X minus left. This X minus is there. Okay, now this X minus can either attack on this one and give this one as a product, or it can attack on this one and can give this one as a product. Okay, so there can be 2 products. We can get either this one or we can get this one. Okay, both these possibilities are there. Okay, so there are certain conditions to decide which is the correct product here. Okay, so these conditions are very important and we need to know these conditions. So the first, very important, very important, this one. So I want to make a box for this one. Okay, this is very important concept that you must remember. You can put as many stars as you can here. Okay, so now see, the first thing is saying that if this R1 and R2, okay, both are primary or secondary, one primary or secondary, anything, then the reaction method followed is SN2 mechanism. Okay, and SN2 mechanism, in this case what will happen? X minus will attack on the less hindered site. Okay, X minus will attack on the less hindered site. Clear? Now if you see the second point, that is, if any one is tertiary out of this R1 and R2, if any one is tertiary, or resonance stabilized primary or secondary. There is any kind of resonance or it is a tertiary group. Then the reaction proceeds by SN1 mechanism. If SN1 mechanism is there, then what will happen? Carbocation formation takes place. Carbocation, and then X minus will attack on the carbocation. Okay, we'll understand this with example. Now see, for example, I'll take one compound, that is CH3O CH2CH3, and I am reacting it with HI. Okay, so now if you see this both side R1 and R2 both are primary and second, like both are here primary, this is also primary, this is also primary, then reaction will proceed by which mechanism? If both are primary or secondary or primary secondary, reaction proceeds by SN2 mechanism. In SN2 mechanism, what will happen? The X minus will attack on the less hindered side. So if you see that this is less hindered, smaller molecule is there, this is less hindered, so I minus will attack here and this bond will break here and H plus will come here. So product here will be CH3I plus CH3 CH2OH. Clear? This is the first thing, first example. Okay, now I'll give you another example. Example 2. If we have like this CH3OC. Okay, so now if you see that this part is tertiary group, okay, and this is primary group. If like this happens, then what is the mechanism? SN2 mechanism is there and carbocation is formed. So if you see tertiary carbocations are more stable, so this will form the carbocation and X minus will attack on the carbocation. So if I take this one with HX, okay, so we will get the product CCCX plus CH3H, or I can write it as CH4. Okay, we will get CH4. Understood the difference here? Here there is a tertiary carbocation can form, right? This group can form a tertiary carbocation. So if tertiary carbocation are very stable, then SN1 mechanism is followed and X1 will go and attack to the tertiary carbocation and we'll get this one. One more important point I'll tell you, example 3 here. If any time, okay, you have a phenol group attached, like benzene ring attached and anything here OCH3 or anything else. In this type of case, every time you must remember bond will break here and one of the products should be phenol plus the XCH3I. Okay, this bond has to break here, there is no other alternative, you need not think anything. If there is a benzene ring O, then this bond, this part must be converted to phenol group. Clear? That is very, very important and there is no other rule here to be followed. Okay, so reactions of ether where cleavage of CO bond is there, that is clear. Okay, now we'll go to, so we'll do some examples here so that it will be more clear. Okay, so as I told you, first one, see here this is tertiary and this is primary. Tertiary group is there, that means carbocation formation will there, and which mechanism will be followed? SN1 mechanism is followed, right? If SN1 mechanism is followed, then this part will form carbocation, I minus will go and attack here. So what will be the product here? We'll get CH3OH. Okay, so I wrote here wrong, right? 1 second. Here it will form CH3OH. CH3OH. Okay, yeah. So this one will form CH3OH and this part will form your Me and I. Clear? This is the first thing. Now second one, if you see, I told you there is a phenol benzene ring is there. If benzene ring is there attached to oxygen, then definitely it will give you phenol. So there is no doubt here, we can close your eyes and write the product as phenol. So H has gone here, so I will come here, so we will get CH3I. Okay, second one, you see this carbon. Okay, this is a secondary carbon and this is a primary carbon. One secondary, one primary, then it is which mechanism? It is SN2 mechanism. In SN2 mechanism, the I minus will attack on the less hindered side. So if you see, this secondary is more hindered, this is less hindered. So I will come here, bond will break like this, H will come here. So we will get cyclohexanol, okay, plus CH3I. Okay, so I hope these examples are clear. Okay, next one. Next we have the second type of reaction, that is electrophilic substitution reaction. So here you have to remember that this group is a electron donating group, right? So if it is an electron donating group, okay, if it is an electron donating group, then it will be ortho and para directing, right? It will be ortho para directing. So if you add Br2, that is, this is your halogenation, right? Halogenation, so we will get two products where OCH3 is there, bromine will be attached at ortho position, and we will have one more product where bromine will be attached at the para position, right? Ortho para product we will get. Next one, RCOCl. So what is this reaction? This is your Friedel-Crafts alkylation. Friedel-Crafts alkylation reaction, right? So here again what will happen? We will get OCH3 and this one COR at one at ortho position, and we will get another OCH3 COR at the para position, right? So we will get again two products, that is your acylation. Now RCl AlCl3, this is your Friedel-Crafts alkylation. Okay, so Friedel-Crafts alkylation, again we will get two products, right? So one will be your OH ortho product CH3, and another will be your para product OH and CH3, right? Any doubt here? I hope all are getting. We'll get one ortho product and one para product. Next we have concentrated HNO3 and concentrated H2SO4, right? So this will give you what? Nitration. Again ortho and para product we will get. So we'll get one product as OH NO2 and another product we'll get OH NO2. Sorry, again I am making a mistake here. This is not OH, these are your OCH3, right? Sorry, this is OCH3, OCH3, OH, OCH3, OCH3. Okay, clear? So these are your four types of electrophilic substitution. So this name reaction is your nitration. Clear? So under reactions of reactions of ethers, right? So we have here under reactions of ethers electrophilic substitution reaction, where we have four types of reaction: Friedel-Crafts alkylation, Friedel-Crafts acylation, halogenation and nitration. Okay, fine. So that's all in this lecture. Now we'll go to the next topic, that is acidity order. So acidity order of phenols are asked. So here you should remember that if electron withdrawing groups are there, okay, then acidity increases. Acidity increases, and if electron donating group is there, then acidity decreases. Okay, now let us see one example. If you have this type of one question, you have only OH, okay, then you have OH with NO2 group, okay, and then you have OH with OCH3 group. Okay, so now first you need to find whether these are electron withdrawing groups or donating groups. Here there is no group, here electron withdrawing group, right, and here electron donating group, right? So electron donating group will decrease the acidity, electron withdrawing group will increase the acidity, right? So if this is 1, this is 2, this is 3, then which is the highly acidic compound here? The second one, because it is having electron withdrawing group. Then OH group, where because it is not having any group. Here electron donating group, least acidity, right? This is the acidic order. Now if the question asks you about the pKa order here, so here one thing you should remember, that more acidic, if it is more acidic, then less pKa. Okay, so this is your acidic order. Now if the question is asked in the pKa order, okay, decreasing pKa order, decreasing pKa order. So whose pK, this is highly acidic, sorry, this one is highly acidic, so its pKa will be least. This is least acidic, its pKa value will be very high. So the pKa order will become this one 3, okay, then 1 and then 2. Clear? pK decreasing pKa order, and this is decreasing acidic order. I hope this is clear. Okay. So now we will do some 15 questions I have brought from all this whole chapter. We are going to solve it quickly and let us see whether we have revised the chapter completely or not. Okay. So this was a homework question that I gave you in my in my previous class. So let us see this question. Okay. So 0.44 gram of a monohydric alcohol when added to methyl magnesium iodide in ether liberates at STP 112 centimeter cube of methane. With PCC, the same alcohol forms a carbonyl compound that answers silver mirror test. So here I told you a hint also that the carbonyl compound which gives silver mirror test are your aldehydes. Okay. Now what is this telling? We have this alcohol. Okay. It was treated with PCC and it gave a carbonyl compound X, and this carbonyl compound, if you took silver mirror test, okay, if you do silver mirror test, then with this gave a positive test. Okay, that means I can say that this is a aldehyde, X must be an aldehyde, and we have studied that alcohols, primary alcohols with PCC give you aldehydes, right? So that means I can say that this alcohol must be a primary one. So now if I see the option, this is a secondary alcohol, I can eliminate, and this is a secondary alcohol, I can eliminate these two options. Now their answer can be either B or D. Now let us read the next part of first part of the question. 0.44 gram of monohydric alcohol when added to methyl magnesium iodide in ether liberates STP 112 centimeter cube of methane. So now if you have this alcohol ROH plus methyl magnesium iodide CH3MgI. Now if you see this is plus, this is minus, okay, this is minus, this is plus. So here what will be the reaction? CH3 will react with this one and this one will react with this one. So we will get here RO minus MgI, okay, plus CH3 and H plus will get CH4, and this CH4 is 112 centimeter cube, right? Now I can say that 1 mole of alcohol reacted with 1 mole of Grignard reagent to give you 1 mole of methane. Okay, so now if I can calculate how many moles of methane was produced, the same amount of moles of alcohols must be there. So I can say that moles of methane produced should be equal to moles of monohydric alcohol that was taken. Okay, so now how to get the number of moles of methane? So number of moles will be equal to given volume by molar volume. So 112 divided by 22,400, right? So this one will give you 0.5 into 10 to the power of minus 2. Okay, so now these many moles of methane was produced. That means I can also say these many moles of alcohols were there, right? Now alcohols given mass is 0.44 gram, right? We know number of moles is equal to given mass by molar mass. So we can calculate molar mass of alcohol here. Molar mass of ROH. So that is your given mass divided by the number of moles, 0.5 into 10 to the power of minus 2. So if I solve this, I will get 88 gram per mole. So the alcohol which the question is talking about, the molar mass of that alcohol is 88 gram per mole. So now you can check in this option number B and D, which is 88 gram. Now if you see here, we have 3 carbon, 4 carbon, 5 carbon. So this formula is C5, okay. Then you have 6 hydrogen, 7, 8, 9, 9, 10, 11, 12 hydrogen, okay, and then 1 oxygen is there. So now if you see 12 into 5, 60, okay, then you have say 12 hydrogen and then 1 oxygen. So if I add this, I'll get 88 gram per mole, okay. So that is why the correct answer for this question will be option number B. You can check the mass of this one, it will be coming around 74 something, so this cannot be the correct answer, okay. So this was a little, I can say, difficult question, okay. So you might have answered or not answered, you can check this answer now, okay. So now we will go to the today's question that we have done from the revision, okay. which of the following alcohols cannot be prepared by the action of a suitable Grignard reagent on an aldehyde or a ketone followed by acid hydrolysis? So they are saying which we cannot synthesize using Grignard reagent. So now you see, for Grignard reagent, first you need any RCOH, okay, and you need any Grignard reagent. Okay, so minimum how many carbons, whatever alcohol you get from here, that can have minimum of 2 carbons. At least it has to have 2 carbons, because one carbon will be from your carbonyl compound, another carbon will be from your Grignard reagent, right? So we cannot, methyl alcohol has only 1 carbon, right, CH3OH. So this we cannot synthesize using Grignard reagent. So the correct answer here will be option number D. Okay. Next, which of the following has the highest boiling point? So boiling point depends on the mass, right? More is the mass, more will be the boiling point. And if you talk about like chain, the straight chains will have more boiling point. So N-butyl alcohol is like this. Okay, this is N-butyl alcohol, option number A. Secondary butyl alcohol is this one. This is secondary butyl alcohol. The third one, isobutyl alcohol, is like this. Okay, and the fourth one is tert butyl alcohol. Right, so you can see here there is chain, here there is chain, here there is chain. This is a linear molecule, so here the boiling point will be highest. Okay, so option number A. Next, the decreasing order of acidic nature of alcohols. So acidic nature of alcohol, if you see, primary, then secondary, and then tertiary. Okay, so primary, secondary, and tertiary. Correct answer is option number A. Next, which of the following pairs can be distinguished by iodine and dilute NaOH? Okay, so this is important question here. Okay, so remember, if any alcohol has this group CH3, COH, and H, if this group is present, then this type of alcohol gives you iodoform test. And in this iodoform test, what is formed? CHI3 is formed. That is your iodoform. Okay, and this iodoform is a yellow precipitate, and we can differentiate that. Okay, so now if you see secondary alcohols, okay, like if you see the one second, N-propyl alcohol and this is 2-butyl alcohol, 1-butyl alcohol, secondary butyl alcohol. So if you see here that we have 1-butyl alcohol and secondary butyl alcohol, secondary butyl alcohol will give you this test, okay, because they have this CH3, CHOH, CH2, CH3 group, right? So this one can be separated using this method. So correct answer is option number B. Okay. Next, in Lucas test of alcohols, the appearance of cloudiness or turbidity is due to the formation of. So this we have discussed. We have ROH plus RX. Okay, this give you, sorry, ROH plus HCl, ZnCl2. This give you RX plus what? Plus water. Now the turbidity is due to the formation of RX, that is alkyl chlorides. Okay, so correct answer is option number D. Next, acetic acid reacts separately with the following alcohols. The rate of esterification is lowest for. So see here, esterification order is 1 degree, then 2 degree, and then 3 degree. Okay, so this is a 1 degree alcohol, this is also 1 degree alcohol, this is 2 degree, this is 3 degree. So these two will not be there. Now out of 1 and 2, so I can say that it prefers less hindered or SN2 mechanism, esterification. Okay, so less hindered will be there in CH3OH, right? Now question is asking you for the lowest one. So lowest one means where there is more hinderedness. So this one is tertiary, here there is more hindered. So that is why the lowest will be in option number D. Okay, this is your lowest. Now if I talk about the fastest, then CH3OH will be the fastest one. Okay, because it is very less sterically hindered. Okay. Next, during dehydration of ethyl alcohols to ethane by heating with concentrated H2SO4, okay, the initiation step is, okay, so this is your option number A form. So when you do dehydration, you have this one CH3OH. First step is protonation of alcohols, CH3O plus H2. Okay, this is step number 1. So that is your protonation of alcohol. So correct answer is option number B. Okay, next, which of the following phenols has the highest melting point? Again, boiling point or melting point. Okay, boiling point or melting point is directly proportional to the mass. Okay, if mass is more, boiling point or freezing point will be more. So now if you see, these all are phenol groups are there, and there is a fluoro, chloro, bromo and iodo. Iodo mass is the highest, so mass of iodo is highest, so that is why boiling point and melting point will be more for option number D. Okay. Next, the correct order of relative acidic strength of phenol, ethyl alcohol and water. So you have phenol, okay, then you have ethyl alcohol, and then you have water. So phenol is having the highest acidic order, okay, then water and then ethyl alcohol. So correct answer is option number A. Here you should remember that there is only one alcohol which is more acidic than water, that is your methanol. Methanol is more acidic than water. Okay, this must remember, important. Okay. Next, in the following compounds, the order of acidity. Okay, so order of acidity we need to find out whether it is a donating group or withdrawing group. So CH3, it is a donating group. Okay, NO2, electron withdrawing group. NO2, electron withdrawing group. Now here you should remember that at para position and at ortho position withdrawing will be better. Okay, so this one will be having the highest acidic order, fourth one. Okay, then 3. Okay, then here donating group means it will decrease the acidity. So after 4, so 2 will be the least one. So we can have already got the answer 4, 3, 1 and 2. So correct answer is option number D. Okay. Now let us see the next question. Which of the following compounds will not liberate hydrogen gas? Will not liberate hydrogen gas on treatment with sodium at ordinary temperature. Okay, so you have to treat it with sodium, right? So that compound must react with sodium. So we have seen that alcohols and acids, okay, alcohols have a properties. We have seen that alcohols reacts with metals, phenols reacts with metals, even acids reacts with metals, but ketones do not react with metals. Okay, so they will not be able to produce hydrogen gas. So correct answer is option number D here. Okay, next, which of the following cannot be made by using Williamson synthesis? Okay, so methoxybenzene, the first one. What is methoxybenzene? This one is methoxybenzene. Can we synthesize this one using Williamson ether synthesis? Definitely yes, you can take this is a sodium phenoxide ion and this one as CH3X. Now if you see benzyl para-nitro phenyl ether, so you have benzyl, that is CH2, then you have para-nitrophenyl. So we'll just write like this here. Okay, so benzyl para-nitrophenyl ether, yes, you can take sodium hydroxide this side as an alkyl halide, then you will get this one. Methyl tertiary butyl will get ditert butyl ether. If you see option number D, this is ditert butyl. Right, now if you want to synthesize, one of them has to be Rx and another time R-ONA, and I told you that Rx must be primary. But here if you see, you have to take like this, the combination you have to take is like this plus O minus Na plus, right? This combination has to be there. Now you see, this is a tertiary alkyl halide, and tertiary alkyl halide will not give you Williamson ether synthesis. So the correct answer for this question will be option number D here. Okay, next, okay, the major product obtained when tert butyl bromide is heated with sodium ethoxide, tert butyl bromide. So that is your, this is right, tert butyl bromide is there. So I'll take bromine here, bromine, and then we have CH3, CH3 and CH3. is treated with sodium ethoxide, that is C2H5O minus Na plus. So I told you if the Rx part is a tertiary one, then the product here formed is alkene group. Okay, so here what happens, I will write like this. This one is like this. Okay, this behaves as a base now. Okay, this behaves as a base here, and it abstracts this hydrogen. This bond comes here, this bromine goes out, and we get here CH3 double bond CH2 CH3. Okay, so this is a formation of alkene. Now if you number it, we'll get 1, 2, 3. So 2-methyl propene. Correct answer is option number A. Okay. Next, an aromatic ether is not cleaved by Hi even at 525 Kelvin. The compound is. So which one will not be cleaved? So I told you that the first option is C6H5OCH3. This one can cleave here easily. Next one is your C6H5OC6H5. So I told you that this bond cannot break, right? So that is why this is the compound which you cannot cleave by Hi even at such a high temperature. Why? Because there is always a partial bond formation here. These bonds are very strong bonds, right? So that is why this has to be option number B. Okay. Next, last question for today. On boiling with concentrated hydrobromic acid, ethyl phenyl ether will yield. So you have ethyl phenyl ether, right? That is, okay. So I told you if you treat it with HBr, whenever there is phenol, undoubtedly the bond has to break here, and this will give you a phenol group, right? And C2H5Br group, right? So you can see phenol group and ethyl bromide group. So correct answer for this question is option number A here. Okay. So yes, now this is a question for your homework. I want all of you to revise this complete chapter, practice this 15 questions, and then try this question. Okay. So okay students, that's all for this lecture, and this lecture is very important as we have revised the complete alcohols, phenols and ethers. Each and every reaction, chapter, example, questions, everything has been done. So yes, this is a must watch video. Please watch it, and if you have any doubt in any of these concepts, do not forget to comment down. I'll definitely address it. Okay. So in my next class, we are going to start about the next most important, a very high weightage chapter, that is aldehydes, ketones and carboxylic acid. Okay. So please stay tuned for the next class. Do not forget to subscribe the channel, and do not forget to join our WhatsApp channel also. Okay. Thank you, and stay tuned for the next class.